A very warm welcome to all of you. Good afternoon. And I'm very glad to see that though it's post-lunch, the room seems full. So I hope you all will find this session very useful. So the agenda for this, see, this is all, we are all attending analytics session, conference. So assuming that you all are either data scientists or have a team of data scientists or are aspiring data scientists, you know, a lot to do with analytics. So what next for a data scientist is a big question that we have often dabbled with. And I am hoping that this panel of distinguished members is going to be able to help me answer that question very well. Yeah? So we'll start with, okay, so to give you the context, we are trying to understand if IoT could be the next frontier, right? So we'll start with introductions and what each of these members thinks about IoT as a next business to look forward to. Dr. Srini.
Hello. So thanks, Geetika. So I think I'll start with whether IoT is the next frontier. Instead, I'll say, can IoT do without data science or analytics? See, today, if you look at the pace of growth of so-called internet embedded things, right from a smart pen to a smart lanyard, to a smart switch, to a smart HVAC air conditioner, to a smart traffic light, to a smart refrigerator. And if you just want to multiply the number of IoT endpoints or number of devices with each one capturing different parameters. For example, there are sensors which capture multiple parameters like temperature, pressure, everything of a room. And imagine the volume of the data that is generated by the sensors, the actuators, tags. Today, I don't know how many of you are aware, almost every retail company, every shop you go has these smart tags associated with every SKU on every aisle, which is monitoring when it's getting replenished so that it can trigger off an alert to an inventory management system, which will trigger a replenishment procedure, and on the way to the supply chain, there is an order book placed for that particular item. Like that, people talk about a smart refrigerator, which detects whether the milk is empty. It will connect to the order management system, order a carton of milk, and milk is on its way to the refrigerator, right? But all of this comes with a price. There are two complexities here. One, which is what are you going to do with the data that's coming up in such a huge volume, velocity. And believe me, if we don't have a meaningful approach to understanding this data is going to be wasted. We're not going to make meaningful sense of IoT itself as a phenomenon. And let me come back to you from the IoT world itself. Over the last 4 years, we have seen hundreds of startups, hundreds of innovations in IoT. But believe me, they all have been at the systems level, creating that next generation wearable, creating some cool, tag, or creating that cool sensor. But where it is getting stopped is the innovation which is needed at the next level. How do you make sense of the data that's generated? There are two complexities here. One is the volume and the velocity at which it's generated. Second is all of these systems in IoT, they are very low power. They have very low computation power. They don't have memory tags, in fact, don't have any power of their own. They work on the receiver's power and work on it. So how do you manage the data that is generated, make sense of it while you have such low power of computation? So key thing is, how do you make sense of the data that is coming in such large volume and such a fast velocity? Look at the continuous sensor data that's coming from all the sensors that say placed in this room at different locations for temperature. It is sensing every 2 seconds, every 3 seconds. The data, it cannot be processed locally because that has limited computing power. So you need to combine it with very innovative data analytics algorithms. So that's why, so let me tell you one very interesting aspect of this, which is it is giving rise to a new data science. Till now, what you were talking about is the data science which has originated from the classical data warehousing, where you talked about historical data. Data warehousing, we're talking about more than a week old archived historical data, doing cubes over it, dimensional analysis, and coming up with historical prediction. But today, with IoT, we're talking about generating a volume of data in 1 hour, which is equivalent to 1 year of retail records as present in a data warehouse, and you need to deal with that. And you need to deal with that before you lose that data, or you are able to store it in a meaningful way and generate insight on it. So streaming analytics, real-time analytics is an area which IoT is springing off as the new necessity in data science. And believe me, being a data scientist myself and having worked in machine learning and different data science algorithms, streaming data analytics, I would say, is still at a nascent stage. So from a data science perspective, IoT offers a great opportunity for next generation innovation. At the same time, it's also fulfilling the need for working with IoT infrastructure in a meaningful way so that all the investments that are gone on in IoT deployments can be meaningfully leveraged by the data that's generated. In some cases, we even come up with intelligent hardware in the middle. Maybe the Intel people can talk about their gateways, which can do edge analytics. Or nowadays people talk about fog analytics. Basically, the idea is because these devices are small, they don't have compute power, but we still need to do analytics on that. So what we do is we offload the analytics to more intelligent devices somewhere in the middle, which again may work with the internet-based cloud on which you may do further level analytics. So there are 3 takeaways. First is, if we have to work with IoT, innovation has to go beyond the first generation IoT systems, which were concentrating more on generating that cool tag or generating the cool wearable or cool embedded system, to software level understanding